All right, we're doing a complicated charge problem. And what's complicated about it? Well, actually, it's mostly using the scientific notation. So here is our setup. We have two charges, and they are 4 meters apart. One has a charge of -2 times 10 to the -6 coulombs. The second one has a charge of -1.8 times 10 to the -5 coulombs. They're both negative. Notice that. We're going to put a positive charge in between these two charges with size 1.5 times 10 to the -6 coulombs. And what we're hoping is that we get it in the spot where the forces exactly balance out and the charge doesn't move. Okay. Let's say that to the right is positive and to the left is negative. So basically the sum of the forces of charge 1 on charge 3 plus the force of charge 2 on charge 3 are going to have to add up to 0. And so this is going to be the heart of the problem. How do we calculate force when we're dealing with Coulomb's law? Well, that's pretty easy. K, which is 9, E9, or 9 times 10 to the exponent 9, times Q1 times Q3, all over my distance, which I've said is x squared. And then because this is in the opposite direction, oh, I said the other way was positive, but that's okay. We'll go with it anyways. So Coulomb's constant times charge of 2 times the charge of 3 over, and this is L minus x squared, or 4 minus x squared. This has to add up to 0 in order for it not to move. Okay, so using my calculator and the EXP button and all the complicated stuff that goes with that, I'm going to calculate this value. So KQ1, Q3 is negative 0.027 over x squared. Okay. Minus KQ2, Q3, which is actually going to turn out to be a plus because that's a negative charge. So we're subtracting a negative. So I'm just going to jump and say that this is 0.243 over L minus x, or 4 minus x squared. And this has to equal 0. Now, you'll notice what's happening here is we're setting up for one of those nice quadratic formula style equations. Okay, we have our unknown, and it's second degree, and so we're going to have to wind up doing a bit of simplification when it's all done. Okay, I am going to multiply through by x squared in order to cancel the x squared off the bottom here. And I'm also going to be multiplying both sides by 4 minus x squared in order to cancel it here. And when it's all simplified and said and done, this is going to be 0.027, because the x squared is canceled. 4 minus x all squared plus 0.243 x squared, and that is all equal to 0. Okay. It's just going to get slightly uglier before it gets slightly better looking, but it's all manageable. Just remember, mostly be able to set up a problem like this. Okay, so let's expand 4 minus x squared. So that's going to be 16 minus 8x plus x squared plus 0.243 x squared. And that's all going to be equal to 0. Now we need to do our multiplication using the distributive property. Negative 0.027 times 16 is negative 0.432 plus, so 0.27 times 8, 0.216 minus 0.027 x squared plus 0.243 x squared has to be equal to 0. And I can actually start to collect terms. Oh, I forgot an x there. Darn it all. Okay. Now I can collect my like terms because I've got a couple of x squareds here. And so 2.43 minus 0.027 0.216 x squared plus 0.216 x minus 0.432 is equal to 0. Okay. I have a quadratic now in terms of x, and x was the distance that charge 3 was placed away from charge 1. You can do this a couple of ways. You could do this using the quadratic formula. There's your a, there's your b, there's your c. Now this problem happens to have been contrived so that x is a really nice number. And we can actually find this out by dividing through by 0.216. Will that actually work? 1x squared plus 1, oh yeah, minus 2. Yeah, that will work. Okay, so I'm going to divide everything. So keep in mind, everybody, this problem has been carefully contrived for this to work out. Ordinarily, you would be doing the quadratic formula. I'm going to simplify it a little bit. Okay, these 0.216's all cancel, and this becomes a negative 2. And so basically, I'm just solving the problem x squared plus x minus 2 equals 0, which factors to x plus 2, x minus 1 equals 0. And so x could be equal to negative 2. And so for some reason, way over there, or x could be equal to 1. In other words, I'm going to be putting this charge 1 meter away from the first charge and 3 meters away from the second charge. Okay, now does this in any way make sense to have that at negative 2? No, it doesn't. Okay, so we're going to say that x is equal to 1 meter. Keep in mind when you're doing these problems, it's set up like a quadratic formula. This one, everything just happened to cancel out nicely. Sometimes they're contrived to work out that way. If you'd used a, b, and c, you still would have come up with the correct roots for this quadratic.